Hello, everyone. Welcome. Today, we'll dive into the world of data integration for GenAI. I'm Gabriel Campos, Solutions Architect at Nexla, and I'm thrilled to be here with Satya Balakrishnan, Senior Solutions Architect at AWS. We're going to build an AWS Bedrock GenAI application that can pull in and chat about GitHub documentation. It's a practical example to show how Nexla and Amazon Bedrock can handle and integrate vast data sets seamlessly. So let's get started. All right, let's take a look at our agenda for today. First, Satya will give you a high-level overview of Amazon Bedrock. We'll dive into the core features and capabilities that make it a powerful tool for GenAI. Then we'll discuss knowledge bases, Bedrock agents, and we'll wrap up this section with vector search. After that, I'll be the one to give you a quick introduction to Nexla and its role in data integration. Next, we'll jump into our demo where we'll show you how we build an AWS Bedrock chatbot with GitHub documentation knowledge. And finally, we'll open the floor for a Q&A session. So feel free to jot down any questions as we go along, and we'll address them at the end. So to kick things off, I'll hand it over to Satya, who will give us a high-level overview of Amazon Bedrock. Satya, take it away.
Thanks, Gabriel. First of all, thanks to everyone who's tuned in to spend your time with us. Good morning, good afternoon, good evening to all of you, wherever you're joining us from. I am Satya Balakrishnan. I'm a Senior Solutions Architect at AWS. And today, I'm going to be walking you through Amazon Bedrock, its key features, and you'll see how it all integrates with Nexla to help you build your dynamic end-to-end RAG workflow. And like Gabriel mentioned, I'll introduce you to Amazon Bedrock, its key features, and I'll explain about what is vector search and vector databases. So let's dive right in. So Amazon Bedrock is a fully managed service that offers a choice of high-performing foundation models from leading AI companies, along with a broad set of capabilities that you need to build generative AI applications with security, privacy, and responsible AI. Using Bedrock, you can easily experiment and evaluate top foundation models for your use case, privately customize them with your data techniques like fine-tuning or retrieval augmented generation, build agents, execute tasks using your enterprise systems and data sources. Since Bedrock is serverless, you don't have to manage any infrastructure, and you can securely integrate your generative AI capabilities into your applications using the AWS services that you're already familiar with. And on this slide, the key feature or the important feature of Bedrock is how easy it is to experiment with, select, and combine a wide range of foundation models. And if you look at the options here, like I mentioned earlier, you have a choice of foundation models from leading AI companies like Amazon, Anthropic, AI21, Cohere, Meta, Mistral, and so on, which are not just accessible easily, accessible easily as easy as an API call. So the takeaway here is flexibility and model optionality to support a wide variety of use cases. Knowledge bases. So to equip foundation models with up-to-date proprietary information, organizations often turn to a technique called retrieval augmented generation, which involves fetching data from your company data sources, enriching the prompts with that data to deliver more relevant and accurate responses. And to retrieve semantically accurate information from search, customers have to first convert their data corpus into embeddings, also called vectors, using a text to embeddings API and store them in a vector database. Today, customers have to perform undifferentiated steps to implement RAG. A knowledge base is here to simplify them. Knowledge bases for Amazon Bedrock eliminates the need to integrate different systems. And so developers can specify the location of their data, like an Amazon S3 bucket, and Bedrock will manage both the ingestion workflow and the runtime orchestration. Now, ingestion workflow includes fetching the documents, chunking them, creating embeddings, and storing them in a vector database. And runtime orchestration includes creating embeddings from the end user's query, finding relevant chunks from the vector database, enriching the user prompts, and passing them to a foundation model. And you can quickly add a knowledge base by specifying a data source like an Amazon S3 bucket, select an embedding model like Amazon Titan, for example, and specify a destination vector database, such as Vector Engine for OpenSearch serverless and so on. And all the information returned from knowledge bases comes with source citation. So this improves transparency and minimizes hallucinations. All right, let's talk a little bit about agents. Agents for Amazon Bedrock automates the prompt engineering and orchestration of user requested tasks. Once configured, an agent automatically builds the prompt securely, augments it with your company specific information to provide responses back to the user in natural language. The agent is able to figure out the actions requested to automatically process user requested tasks. It breaks the task into multiple steps, orchestrates a sequence of API calls and data lookups, and maintains memory to complete the action for the user. And using agents for Bedrock, you can automate tasks for your internal and external customers. Take, for example, managing retail orders or processing insurance claims. Now, an agent powered generative AI e commerce application can not only respond to questions like, do you have this jacket in blue, with a simple answer, but can also help you with the task of updating your order or maybe even managing an exchange. All right, let's talk a little bit about vector database and search. Vector databases allow you to build, store, search, manage, and scale vector embeddings so that you can perform vector search on top of those embeddings. This improves accuracy, helps you provide contextually relevant results for your business use cases. And vector search is an ability to find similar items or entities based on their numerical representations, known as vectors. So, vector search requires items like documents to be represented as high dimensional vectors in the vector space. And each dimension of a vector represents a particular feature or attribute of the item. By representing items as numerical vectors, it becomes easier to calculate similarities using mathematical formulas like Euclidean distance, cosine similarities, and so on. Now, let me explain this with an example. Now, most applications that we use from a day-to-day basis has a search box interface. So let's say you wanted to buy a couch from Amazon.com, and you go to the search box and you type in a cozy place to sit by the fire. And if you type this exact phrase on Amazon.com, you might see items like fire pits, heating fans, and home decoration items which you may not have intended to see. Now, the problem here is couch manufacturers probably didn't use the words like cozy, place, sit, or fire in their product titles or product descriptions. So now, if you introduce an embedding model to this solution, a type of model that can encode a large body of data into n-dimensional space where each entity is encoded into a vector. So now if you run this exact same search, we'll find vectors nearest to an encoded document. So this helps you in finding and returning most semantically similar documents. All right, what vector databases can you use with Bedrock knowledge bases? Knowledge bases for Bedrock works with popular vector databases like our vector engine for Amazon OpenSearch Serverless, Redis Enterprise Cloud, and Pinecone. And coming soon, we'll be adding support for Amazon Aurora, which is our relational database management system, as well as MongoDB. That's all from me for now. So I'll hand it back off to Gabriel to take it from here. I'll see you again in a bit to walk you through these parts in action during the demo. Gabriel, back over to you.
Awesome. Thank you very much, Satya, for this great overview on AWS Bedrock. I think now it's my turn to introduce you to Nexla. So at Nexla, we've been all about transforming data engineering for the past 7 years. Our main focus is getting data users the ready to use data they need. So we leverage metadata to drive integrations and bring a lot of automation and collaboration to the table. We work with a variety of industries from e-commerce and logistics to healthcare and finance, as you can see. And our platform handles everything from data ingestion to validation and also transformation, making it very flexible and scalable for different needs. Security is also a big priority for us, and we've got all the certifications to prove it. So this ensures that our clients' data is always protected and compliant with regulations. Recently, we've been also focusing on AI. So our platform seamlessly integrates with many LLM models and AI services, including Bedrock, providing clean and enriched data to fit all your AI needs. And by the way, we're also proud to be rated 4.9 stars on Gartner Peer Insights. So, in summary, Nexla is here to support a growing number of data users and use cases with robust automation and collaboration. So, Nexla is a data plus AI converged data integration platform because we handle a lot of different types of integration patterns in one single tool. In many enterprises, data is scattered across various systems, including SaaS applications, on premise deployments, and homegrown databases. And traditionally, integrating this data requires a mix of different tools and custom code, which creates a complex and cumbersome process. Nexla simplifies this by serving as the central point for all of these integrations. Our platform replaces the need for multiple point to point tools with a unified solution. Nexla's metadata intelligence layer abstracts away the complexities of connecting and formatting data, automatically creating uniform data products from diverse sources. This means that users can easily access and utilize data without worrying about the underlying integration challenges. We like to say that we make data engineering composable with various Lego blocks that can connect seamlessly. Our platform supports many different sources, as I mentioned, and our metadata intelligence layer automatically creates data products from your all of these diverse data sources, making them look and feel the same. So users don't need to worry about connecting or formatting data because Nextfly is handling it all. So you can also use no code, low code functions to transform, filter, and validate data before landing that into any knowledge base for AI systems, for example. And for those who prefer, there's also the option to use SQL, Python, or JavaScript, which then becomes reusable. This abstraction layer allows for diverse use cases. Data scientists can work in pandas notebooks, AI developers can use vector databases, and business users can create dashboards, all without writing any code. Nexla's platform makes data integration and deployment efficient and accessible, empowering your teams to focus on insights and innovation. Now, let's talk about deploying RAG. This involves tackling some significant challenges. We'll explore what these challenges are and how to effectively address them. At Nexla, we understand that RAG applications are also a data engineering problem. Why? Because of three main challenges. First is the data complexity. Enterprises handle massive amounts of data from diverse sources, as I mentioned. And this data comes in various different formats, such as structured, semi structured, and unstructured, making integration a complex task. Robust data pipelines are needed to manage this diversity seamlessly. Then we also have knowledge maintenance. Keeping data accurate and up to date is crucial. This involves regularly refreshing data sets with new information and ensuring consistency across all of your sources. Automated processes for data validation, enrichment, and updating are essential to maintain high quality data over time. And last but not least, infrastructure. Supporting RAG systems requires scalable and efficient infrastructure. This means optimizing data retrieval and processing speeds to handle large volumes dynamically. Scalable architectures, leveraging cloud based solutions, and distributed computing are necessary to ensure high performance as data volumes grow. So, in summary, effective RAG deployment demands robust data engineering to manage complexity, maintain knowledge accuracy, and build scalable infrastructure. So, to address the data engineering challenges of deploying RAG, we're leveraging the combined strengths of Nexla and AWS Bedrock. For this use case, Nexla will integrate data from GitHub repositories, pulling markdown files and storing them in S3. Nexla automates the retrieval of this data, including metadata, on a scheduled basis, ensuring consistency and timeliness. Our platform also provides robust orchestration and monitoring capabilities over these pipelines, allowing us to track data flows, detect anomalies, and ensure data integrity throughout the process. Optional transformations enable data cleaning and enrichment before seamless delivery to Bedrock knowledge bases. And then Once Nexla has integrated and prepared the data, AWS Bedrock will utilize it to perform vector searches. And Bedrock's powerful AI capabilities and infrastructure will handle all of the high performance data retrieval and processing, enabling us to build an efficient RAG system that leverages the data provided by Nexla. So, by combining Nexla's automated data integration and orchestration with AWS Bedrock's advanced AI processing, we can effectively address all of the challenges of deploying RAG systems, ensuring both seamless data management and also powerful AI performance. So now I'll give you a quick demo on first how the data was landed from GitHub repositories using Nexla to AWS Bedrock knowledge bases on S3. Okay, so welcome to Nexla. This is the Nexla platform, our integrate section where you can see all of your data flows. In this example here, I have a project that is dedicated to this integration from GitHub to transformations and finally S3 for Bedrock knowledge bases. In this example, we're getting from a GitHub repository that has EKS AWS best practices and a lot of documentation around these services. So as you can see here, if I open up the source settings, I can see some steps that are being run on Nexla to pull all of these documents from GitHub. So this is a multi-step REST source where first we are querying for all the markdown files on GitHub and then extracting all of these contents to Nexla. So this is a three-step REST source that first gets all of the markdown files. In the second step, we get the URL for every file we need to download from GitHub. And then in the third step, we are just extracting all of the content from every markdown file. So that's ingested to Nexla. Then Nexla metadata intelligence layer will leverage what we call a next set. So a next set is just that abstraction that I mentioned before that basically makes every source and destination look the same. Nexla is totally source and destination agnostic, so everything you pull within the platform is going to be represented in the same exact way. So if I open this next set up, you're going to see the content for every markdown file that we've pulled from this repository. So as you can see, we have many different documentations, and optionally, you can see that as a JSON as well for some cached samples. From this point, you can then run some transformations on top of this data. In our example, we're not transforming anything on the data itself, but if this was, I don't know, a specific data set that you want to run some transformations on top of it, maybe you want to clean some data, you could also do that within that step by leveraging Next Set Designer. So the Next Set Designer enables you to quickly create rules, no code, low code, and code transformations to create ready-to-consume curated data products within Nexla. And then later, you can land these data products anywhere to any destination. And in this example, you can land them on Amazon Bedrock knowledge bases as well. So by adding different transformations, you can create your ready-to-consume data products from this screen. In this example, the single transformation that we're running is basically to make sure that we also have the file name along with the content. Why is that? Because sometimes we get the contents from a file, but we don't know from where that file came from, and that's also a good information to have. So in this example, Nexla is leveraging metadata coming with the file and stitching that together to land that differently. You can maybe perform different metadata operations. Maybe you want to get the data of ingestion within Nexla and land that as well to make sure you have timely information and up-to-date information for your knowledge bases. And whenever you're asking an AI, hey, what is the date for this document, you can also get that answer back. And basically, in the last step, we're just sending that to S3 for Bedrock knowledge bases. And this runs on a cron schedule. So basically, Nexla enables you to easily orchestrate that flow if you want to pull for new files every 15 minutes, every hour, or maybe every day, depending on how often your documentation gets updated. And then we'll make sure that on your destination phase, your files are always up to date and you're always retrieving relevant, updated information from AWS Bedrock whenever you ask a question on the chatbot interface. So really quick, I'll show you how quick it is to leverage a GitHub connection within Nexla by creating a new data flow from GitHub. So if we click here on new data flow, we have several different types of data flows within Nexla. I'll go with the flex flow, which is the most flexible one. Then we create a data flow, and here's our source selection screen where we have many different services to choose from: file systems, databases, email, APIs, anything. So Nexla is able to connect to more than 200 different sources, and the transformation stage and the next set detection will be the exact same for every source you see here. So that's the whole flexibility and velocity we bring to the table whenever you want to create a new data flow. So whenever you want to populate AWS Bedrock knowledge bases with different systems knowledge, you would go to this screen, select your system, and then you'd be instantly sending that knowledge across to AWS Bedrock, and you can instantly query Bedrock for that information. So in this example, I'm searching for GitHub, and here I have my connector. I can choose my credentials, so Nexla has also full role-based access control over credentials. I could create a new one optionally if I wanted to, but here I have already my GitHub credential. Then when I hit next, I have some different endpoints that we can pull from GitHub. And here, what I'm interested on is to extract files with a specific extension. At this point, I would choose which extension to pull and also what repository I want to pull this from. Optionally, then, I can change my scheduling options to accommodate for what I mentioned before. So depending on how often you get your documentation updated, you can choose from many different scheduling options at this point as well. So on the repository identifier, I will put the AWS EKS best practices repository. And then on the extension I'm interested on, it's Markdown. So I'll put MD, which identifies Markdown files. Now I should adjust my scheduling options to pull files every day. And then I can also set a name to my source. So EKS best practices. And then I can create the source. And then Nexla will leverage all of these metadata intelligence to generate a new next set. Okay, now I pause here and I'll go to another data flow. Hold on. Because I don't want to wait that for that to finish. Okay, now we have a detected next set from this source, and from now on, we can leverage these transformations I mentioned before, and then land that on any destination. Optionally, if I don't want to run any transformations on top of this data, it's just a matter of clicking on Send to Destination, and the same set of connectors will appear because everything within Nexla is bidirectional as well. So from every system we read from, we're also able to write from whenever that's also acceptable by the system. In this example, we're sending data to Amazon S3. You can choose from the same range of credentials, and then you choose where to land this data on. And you can also choose from many different data formats, and Nexla will handle the conversion automatically for you if needed as well. In this example, we can also set a dynamic directory name if you wanted to order by, I don't know, date, or maybe file name, or maybe repository name. You can always do that with the Nexla by using and leveraging macros on the destination phase. So in this example, I'll land this data on our demo out bucket and then say that this is going to be S3 for Bedrock. That's going to be the directory I'm going to send these files to. Optionally, I could send different file name prefixes and also custom headers to each output file if I wanted to. If you have a huge amount of files, you can also parallelize these flow right away by selecting different speed factors on this dropdown. And then Nexla will automatically parallelize your data flow to handle a huge scale of data ingestion within Nexla. Then when I hit done, sorry, let me say that again. Then, when I hit done, I have my created destination right away. And once I activate it, I'll see records flowing from source to my optional transformations landing on my destination for AWS Bedrock knowledge bases. Yeah, so I think that was for the Nexla side. And then now we will see with Satya how we can leverage these knowledge that Nexla is landing on S3 on AWS Bedrock. Thank you. And Satya, I think now it's your turn.
All right, thanks, Gabriel. So just to recap, Gabriel showed us how we can ingest documents in specific format, data formats into um, Amazon S3. So in this specific example, he showed how we ingested EKS best practice guides, which is right here, into S3. So from a user experience perspective, what we're trying to demonstrate is building an interactive interface or a chat interface or giving you the ability to chat with these documents. These could be anything like um, it could be Atlassian Confluence docs or any other external data source as well. And the source files for this website lives in GitHub, which is this which Gabriel walked us through ingesting into Amazon S3. So I'll take you behind the curtain into AWS console and see how we work with AWS knowledge Bedrock knowledge bases. So I am in the management console for Amazon Bedrock, and we'll go into knowledge bases here. And to create a knowledge base, it's as easy as just specifying your knowledge base name. So let's say my demo knowledge base, enter a description. You can specify an IAM permission, a principal with authorization to access the S3 bucket where your data is sourced. I'm going to create and use a new service role, and the data source here in this case is S3. If I hit next, and you can give your data source a different name, and then browse S3. You can select your specific S3 bucket, and now you would just select the embeddings model. So remember, the data corpus need to be converted into embeddings and stored in a vector database. So the second step here is we choose an embeddings model. Let's say I go with Amazon Titan. And the last step is I have to select a vector database. In this case, I'm going to just use the default option to create a new vector store, which would use a collection on Amazon OpenSearch serverless vector engine. And that's pretty much it. So what I've done is I've already pre-created a knowledge base. When I hit create, it's going to start ingesting the data, chunking them, converting them to embeddings, and storing them in a vector database. So the sync process could take a few minutes, or depending on the data size, it could take longer. But in my case, just to save us some time, I've pre-created a knowledge base, so which is right here. And let me make this a little bigger so it's visible. All right. So all we can do right now is select a model. This now I'm selecting a foundation model, which is going to help answer questions. So let's say I go with Claude Instant. And I can start asking questions. Let's ask, what are pod security best practices on EKS? So what's happening behind the scenes here is this question is also broken into embeddings. Relevant chunks are retrieved from the vector database. The prompt is enriched, sent to Claude Instant, which is looking up the knowledge base and giving us this answer. Like I mentioned, the results come with source citations. So this improves accuracy and reduces hallucinations. Right? So we can also ask follow-up questions here. So let's say um, I want to implement pod security policies. So how can I implement? Okay, to implement pod security standards, you can enable pod security admission. So let's ask another follow-up question. In this case, I'm going to use just the abbreviation. Let's say if it's able to understand. Can you show me an example PSA? Okay, so I did. All right. So that's pretty much it from my side. So just to recap, we ingested data relevant to this best practice guide into Amazon S3 bucket, built a Bedrock knowledge base. And a couple of advantages of using Nexla here are, now the source files here are all in Markdown format. So let's say if you wanted to remove some headers that are related to styling or any frameworks that you're using with Markdown, you can create an exit which removes those headers. And additionally, let's say if this source is constantly updated, and let's say if a developer makes a pull request, commits a change, makes a pull request, and pushes it to GitHub. Now, since Nexla has the ability to periodically push, so you have a dynamic end-to-end RAG workflow with Nexla and AWS. Right, with that, I'm going to stop share, hand it over to Gabriel. If you have any questions, feel free to put them in the chat window here, and we'll be happy to answer them.
Awesome. Thank you very much for that, Satya. That was a great demo. And now I think we'll do the Q&A session right now. I see some questions on the chat already. So yeah, let me start with some for you, Satya, on AWS Bedrock. So first is, what data formats are supported by knowledge bases for Amazon Bedrock?
Okay, yeah, thanks for that question. I presume you're asking about file formats. So supported formats right now include common file formats like PDF, text, docx, Markdown, HTML, like we saw just now. We also support CSV, XLS, and XLSX file formats right now. The files are just uploaded to S3. You configure your knowledge base to point to that data source, and knowledge base does the rest.
Awesome. Thank you very much. I see one for Nexla as well. So can Nexla support data integration from SharePoint along with GitHub repositories? And if so, how does it manage data from both sources and ensure seamless delivery to AWS Bedrock? Great question. So yes, Nexla has a SharePoint connector out of the box. So you can also bring business documentation and relevant documents to your company to AWS Bedrock knowledge bases by creating the same integration flow as you have for GitHub. And Nexla will handle everything as a separate data flow. So you mentioned how does Nexla orchestrate these two different sources into S3. So you can create different pipelines. So you'll have also individual monitoring over these data pipelines. And at every resource level, Nexla also provides you with error management capabilities. So by creating a new data flow, Nexla will be able to deliver data to the same S3 bucket seamlessly. Great. So I have one more for Amazon Bedrock. So how does knowledge bases for Amazon Bedrock chunk the documents before converting them to embeddings?
Okay. By default, a knowledge bases automatically splits it into chunks of 200 tokens. It ensures that a sentence is not broken in the middle, and there is an overlap of 20% token that is maintained between two consecutive chunks. Um, when I walked you through creating a knowledge base, there were also additional options. So, in besides default option, you can prefer to use a fixed size chunking, in which case you specify the maximum number of tokens per chunk and the overlap percentage between chunks. And finally, you also have an option of creating one embedding per document. This is an option which you would use when you've already pre-processed your documents by splitting them into separate files, and you don't want Bedrock to further chunk your documents.
Nice. And a last one for Nexla. Does Nexla support PII masking before landing data to S3? If so, how is this process managed? So yes, we do have many PII masking transformations out of the box. You can optionally mask your sensitive fields. You can maybe anonymize your data, but keeping them unique. So maybe you have like fields that individually represent a person or a user, you can easily hash them using no-code transformations within Nexla, keeping your data unique and the same data characteristics you would have with non-masked data. But now you're landing the data masked already, so you don't need to do any further processing later. We do have many use cases for finance and healthcare where Nexla anonymizes data before landing that into downstream systems. Thank you all for joining us today for our webinar with Amazon AWS Bedrock. We hope you found the session valuable and that you have found practical insights into scaling your data integration for GenAI with Nexla and AWS Bedrock. As a next step, we invite you to schedule a demo to learn more or explore Nexla on the Amazon Marketplace. Thanks again, and we'll see you next time.